Dear student, welcome to all of you in my online maths video class. In our last video class, we discussed related formula of exercise 3.5. But one student just requested me to solve one question from exercise 3.4. Therefore, here I am going to explain one question from exercise 3.4. Trigonometry for that is the T4 video. The question number first, third part. Here the given y is equal to 2 sine 2x for every x belongs to a real number. We have to find its graph and range as well as period of this trigonometric function. Dear student, here on page number A149, one formula is given. The period of the function a sine bx is equal to 2 pi upon modulus b. Here 2 pi is what? We know that 2 pi is the period for sine and cosine function. But if the function is in this form a sine bx, here a and b may be real number, in that case its period will be 2 pi upon modulus b. On this basis, here the period of 2 sine 2x is 2 pi by b means 2 pi by 2 means pi. It means after this period, the graph will repeat itself. Now let us construct a table. Here we know that y is equal to 2 sine 2x. So here we first write the value of x and then their corresponding value of y. If we put x is equal to 0, at that time its value will be 2 sine 2 0 means 2 sine 0. And we know that sine 0 is 0, therefore y is equal to 0. Getting? Now we find the value of this function at x is equal to pi by 4. And here the sign in the given function is y is equal to 2 sine 2 into pi by 4. So 2 sine 2 pi by 4. 2 sine 2 pi by 4 will be here means 2 sine pi by 2. And we know that sine pi by 2 is equal to 1. Therefore, here it will be 2 into 1 means 2. Okay? Means at x is equal to 0, value of y will be 0. And at x is equal to pi by 4, value of y will be 2. Getting? Now we find the value of the given trigonometric function at x is equal to pi by 2. If x is equal to pi by 2, then y is equal to 2 sine 2 into pi by 2. 2 and 2 cancel, it will be 2 sine pi. And sine pi is what? 0. Therefore, again its value will be 0. It means at pi by 2, the value of the given function is equal to 0. Similarly, we can calculate the value of the function at x is equal to 3 pi by 4. Then y is equal to 2 sine 2 into 3 pi by 4. Here its value will be 2 sine 3 pi by 2. But sine 3 pi by 2 is equal to minus 1. Then its value will be minus, like this way. Okay? In this way, we can find the value of 0 degree, pi by 4, value of this function when value of x is equal to 0 degree, pi by 4, pi by 2, 3 pi by 4 and pi. When value will be pi, then again it will be 2 sine 2 pi and its value will be 0. Now we try to plot this here in this graph. Then if x is equal to 0, then value will be 0. If x is equal to pi by 4, then value will be 2 here. The value will be 2. Okay. If value is pi by 2, then its value will be 0 here. If pi by 2, then value will be 0. If 3 pi by 4, then it will be minus pi by 2. And if it's equal to pi, if x is equal to pi, at that time, the value of the given function is equal to what? Again 0. Now we just join these dots and try to make a graph. We find that After pi, the graph repeat itself. Therefore, here the period whatever we have decided that is pi, it is correct. Now we write the graph, from the graph the range of the function. We know that the value of the given function is varies from -2 to 2 at whatever value of x. Therefore, the range of the function will be -2 to 2. Okay, I think you understand this. Now let us solve one more question from this exercise 3.4. Let us see the first question of exercise 3.4, question number 2. The first question is, draw the graph of the following function, and the first one is cos x by 2, and also write their range and period. So here given y is equal to cos x by 2, where for every x belongs to real part. The period of the function a cos bx is 2 pi upon modulus b. This is the work as a formula. Let us learn it. You should learn it. The period of the function a cos bx is 2 pi upon modulus b. Therefore, hence, the period of cos x by 2 is 2 pi upon modulus 1 by 2, and modulus 1 by 2 will be 1 by 2 only, and when 2 will be here in numerator, it will be 4 pi. It means here in this case the trigonometrical function y is equal to cos x by 2, the period for this will be 4 pi. It means after 4 pi, 0 to 4 pi, after 0 to 4 pi, the graph will repeat itself. Okay, after 4 pi, the graph will repeat itself. Okay, it means the period 4 pi means this. Now we try to make the table of values. Table of values. You can take other value of x also, but according to my convenience, I am taking this value. Here, if x is equal to 0, look here. If x is equal to 0, then cos 0 by 2 means cos 0, and we know that cos 0 is equal to 1. Okay, it means at x is equal to 0, value of y is equal to 1. Now, if we take x is equal to pi by 2, then y is equal to cos x means what? Pi by 2 into 1 by 2 means cos pi by 4. And cos pi by 4, we know that its value is 1 by root 2. And 1 by root 2 means 1 upon 1.414. If numerator is 1 here and denominator is 1.414, it means numerator is less than the denominator. If numerator is less than denominator, its value will be always less than 1. So therefore, its value will be less than 1 finally, that is 1 by root. Now again, if we take x is equal to pi, then what happens? Try to understand. If x is equal to pi, if we take, here it's over, if we take x is equal to pi, so cos x by 2, cos x by 2, if we take x is equal to pi, then it will be cos pi by 2, and we know that cos pi by 2 is what? 0. Therefore, cos pi by 2 is equal to 0. Getting? Now, if we take x is equal to 3 pi by 2, here x by 2, and at the place of x we write 3 pi by 2, 3 pi by 2, then it will be cos 3 pi by 4, cos 3 pi by 4, and cos 3 pi by 4 can be written as cos pi minus pi by 4. Cos pi minus pi by 4 is equal to cos 3 pi by 4, and pi minus pi by 4 here ASTC. So it will be in second quadrant, and in second quadrant its value will be negative, and here cos pi by 4, and we know that 1 by root. So here its value will be 1 by root. Getting? Let us see, check for more values also. Now our function is y is equal to cos x by 2. If we take x is equal to 2 pi, then 2 and 2 will be cancelled, and it will be cos pi, and value of cos pi is equal to minus 1, then it will be like this. Similarly, we can find the trigonometric value y at x is equal to 5 by 2, that will be minus 1 by 2. At 3 pi it will be 0, at 7 pi by 2 it will be 1 by root 2, and at 4 pi it will be 1. Similarly, we can find it. Now we just plot this. Here the maximum value, that is 1, and the minimum value is minus 1. Okay, at x is equal to 0 it will be 1, at x is equal to pi its value will be 0, at x is equal to 2 pi its value will be minus 1 here this is minus 1, and similarly at 3 pi its value is 0, and at 4 pi its value is 1. Now we just join this dot and make a required graph. The graph will be like this way. This is the graph of trigonometric function y is equal to cos x by 2. Okay, on this basis here we find that the value of the function varies from minus 1 to 1. Therefore, range of the function is y such that y belongs to a real number from minus 1 to 1. It means its range will be minus 1 to 1. Its range we can write here like this way, minus 1 to 1. The range of the function will be like this. Which function? This function y is equal to cos x by 2. In this way, you can solve the other question of exercise 3.4. Let us see the next topic. Now let us prove some more formula whatever related to exercise 3.5. One of them is tan x plus y plus z is equal to tan x plus tan y plus tan z upon 1 minus tan x tan y minus tan y tan z and tan x tan z. Similarly, cot x plus y is equal to cot x cot y minus 1 upon cot y plus cot x. And here cot x minus y is equal to cot x cot y plus 1 upon cot y minus cot x. One by one we try to verify this. Here first of all we take the first one, its left hand side. Here left hand side, that is tan x plus y plus z. Okay, we can write it like this way, tan x plus y and here plus z. Now use the formula tan a plus b, to tan a tan b, tan a plus tan b upon 1 minus tan a tan b. Its value will be like this way, tan x plus y plus tan z upon 1 minus tan x plus y into tan z. Okay, very simple. About this I explained yesterday that tan x plus y will be tan x plus tan y upon 1 minus tan x tan y. So if we take here x and here y, then tan x plus tan y upon 1 minus tan x tan. Okay, now we just explain this, expand it, and it will be tan x plus tan y upon 1 minus tan x tan y and plus tan z, and its denominator is 1 minus tan x plus tan y upon 1 minus tan x tan y into tan z. Okay, now if we simplify this, then it will be tan x plus tan y, and here it will be tan z minus tan x plus tan y, and like this way tan z minus tan x tan y tan z. Here it is wrong, here tan x tan y and tan z. It will be here minus tan x tan y tan z. Okay, but in denominator it will be 1 minus tan x tan y, 1 minus tan x tan y. Okay, like this way. Similarly, the denominator of this, how it will be? It will be 1 minus 1 multiplied here, so 1 minus tan x tan y, and this multiplied to this, so minus tan x tan z. Again here it will be minus tan y tan z in denominator, and whole upon 1 minus tan x tan y, 1 minus tan x tan y. Now denominator of the denominator and denominator of the numerator will be cancelled, and finally we get the left hand side, this value, which is like this way, tan x plus tan y plus tan z minus tan x tan y tan z, and here whole upon 1 minus tan x tan y, 1 minus tan x tan y minus tan x tan z minus tan y tan z. In this way we can verify this formula. Okay, here all the things are given in the book. If you have any doubt, you go through the book once again, and if you again not able to understand, then you should write in comment section. I will explain one more time. So here now let us see the next verification related to cot x plus cot y and cot x minus cot y. Here cot x plus y can be written as cos x plus y upon sin x minus y. Okay, I know that cos x plus y is what? Cos x plus y. Cos x plus y is cos x cos y. Cos x cos y minus sin x sin y. Similarly, its denominator will be sin x minus y is what? Sin x cos y, sin x cos y, and minus sin x cos y minus cos x sin y. Okay, we just write cot x plus y is equal to cot x plus y upon cot x minus y. Cos x plus y upon sin x minus y, and cos x plus y is cos x cos y minus sin x sin y, and expansion of sin x minus y is sin x cos y minus cos x sin y. Now what we do in next step? In next step we just divide the numerator and denominator by sin x into sin y. Sin x into sin y. If we divide it by sin x and sin y, then it will be cos x upon sin x cos y upon sin y, then it will be cot x cot y cot x, cot y, and here sin x and sin y will be cancelled. It will be -1. And here when we divide sin x cos y by cos x by sin x sin y, then sin x and sin x will be cancelled, and that will be cos y upon sin y means cot y, minus again sin by sin y will be cancelled and it will be cot x. In this way we get this relation. Similarly, if we put the negative sign, so here it will be cos x minus y upon sin x minus y. Something mistake, I think. Before that, if here plus, now this will be plus cot y plus cot x, cot y plus cot x. They 1 minute. If here plus, then here plus, and then here also plus. But if this plus, then this will be minus sign, and here will be plus sign, like this way. Cot x plus y will be like this way, cot x cot y minus 1 upon cot y plus cot x. Now if here it will be minus, then here also minus, and here also minus. In that case, here will be plus and here will be minus. Then here plus, here minus, like this way. Cot x minus y will be cot x cot y plus 1 upon cot y minus cot x. In this way, we can verify this formula. There are some more formula given to verify. It is important also, but you should go through it and try to find its verification also, and then start some more question of exercise 3.5. Here up to 20, very easy, you can solve it. If you have doubt, then you must ask through WhatsApp, and I would like to give the PDF of this solution. Next day I will solve some question of exercise 3.5. Thank you.